Alright, so section 6.2, okay, we're going to find the volumes, okay. So, to find the volumes of a three-dimensional solid region, what kind of the formulas you can remember for, say for example, for rectangular box, okay, okay, we know it may not be a square for the base, okay, it may say this is a rectangle for the base, length, width, and height. Do you still remember how we find the volume for a rectangular box? What should we do? We use length times width, which give us area, right? Area for the base, and then use that times by what? The height, right? So, area of the base times by height, length times width times height. That's for a rectangular box, right? How about for a cylinder? If the base area is radius r and then height is h, how to find the volume for this cylinder? Remember, volume A equals area of the base times by what? Height h, right? But how to find the area, the base area, if it is a circle? Remember how we find the area for a circle? With radius r. What is the formula? Pi times r square, right? So, pi r square. This is the area for the base, and then times by what? The height of the cylinder. You guys, was good? Okay, now we're going to look at, sometimes we have what? A three-dimensional solid region. It's not a rectangular box. It is not a cylinder. But are we still able to find the volume of the three-dimensional region, solid region? Okay, so for example, look at this picture. It looks like a bread, right? Not irregular. It doesn't have a regular shape, right? It's like a bread there, right? Laying down, irregular, or it looks like a lamb or something like meat, something. Okay, so if we're given a solid region looks like this, okay? Are we able to find the volume of this solid region? Then that's how, we learn section 6.2, find the volumes, okay? Alright, I'm going to ask a volunteer to read this paragraph for us, okay? And also including this formula, okay? Who want to read? Anyone? Dave?
Let S be a solid that lies between x equals A and x equals B. If the cross-sectional area of S in the plane P of X, or P sub
Piece of X, yeah,
sub
yeah,
X,
yes.
through X and perpendicular to the X-axis is A of X, where A is an integrable function, then the volume of S is volume equals from B to A of X d of X.
Okay, thank you. Okay, yeah, volume equals, yeah, that's fine. Yeah, that's fine. Volume equals integral from A to B, A of x dx. Okay, so now let's look at this solid region S. Okay, this solid we call it solid. Okay, then how to find the volume of it? Okay, it doesn't have a regular shape, not a rectangle, not cylinder. Okay, so what we do is, okay, it says the solid varies between x equals A and x equals B. See? This is A of A, right? Capital A of A. This is capital A of B. Okay? So, it varies between x equals A and B, right? Between A and B. And then, if we have a what? A cross-section area of S in the plane P of X. Okay? So, what is this plane P of X? We're going to draw a vertical plane, okay, which passes through this point when x equals x, okay, and then this plane is perpendicular to this x-axis and pass through the point when x equals x. We draw this plane P of X, okay? So it's like a knife, right? It's like a knife which is perpendicular to this x-axis. We cut the bread. Think about that. We have a loaf of bread, right? And then we use a knife to cut it through, okay? Cut it through, just like that, right? Okay, so if this is the case, okay, we're going to have what? A a cross-section area of S. Okay, so do you see this cross-section area of S? S is solid region, okay? So if we use a knife to cut through this yummy bread or meat, whatever, okay, we have an intersection. Right? We will have intersection, right? We call cross-section area of S in the plane, okay? Through X and perpendicular to the X-axis, which is the A of X, okay? So A of X is this intersection region, okay? Intersection, okay? Yeah, intersection plane, okay? Intersection plane. We call it A of X. If A of X is an integrable function, means we can integrate this function A of X. Why is A of X? Because what? This plane P of X pass through when X equals X, okay? And then perpendicular to the X-axis, okay? So this intersection area A of X is a function of X. We could figure out A of X in our calculation. I'll show you very soon, okay? So if this is A of X is area of this what? Intersection region, okay? Intersection region, okay? So to find the volume of this entire bread or entire solid, okay, solid, what are we going to do? We're going to integrate of A of X, okay? And then when X varies between what? A to B. Can you understand why this is the case? Just like this, volume of this rectangular box and also the volume of this cylinder, right? We're going to use what? We're going to use a base A, the area of the base, okay, times by what? The height H, okay? Same thing here. If we know any intersection A of X here, this is like intersection. We're just going to integrate, okay, this is when X equals X, okay? We're going to integrate this A of X, okay, from what? A to B, okay? So eventually that'll give us what? Give us the volume of this solid S. You guys, can you imagine that? Okay? If you cannot, in our textbook, okay, it tells us in detail, okay? You can look at that, okay? However, I believe you guys can understand that, right? So this A of X is just any arbitrary cross-section or intersection, okay, with when X equals X, okay? And then we just integrate this A of X, okay, this area, when X varies between A to B. That will give us what? The volume, okay? Well, the key is we need to find what? A of X. Once we know the A of X, we just need to integrate, okay, for X varies between A to B, then we can get the volume. You guys, sounds good? Alright, now let's look at our specific question, okay? So we have 4 examples. Of course, we will look at these 4 examples at first, okay, one by one, alright? So these examples hopefully will help you to understand how can we get the volume problem, okay? I'm going to ask volunteer to read this first exam A, the 3 lines. Who want to read? Tyler?
Find the volume of the solid obtained by rotating the region bounded by the given curve about the specific line. Sketch the region, the solid, and a typical disk or washer. Y equals X plus 1, Y equals 0, or X equals 0, X equals 2, about the x-axis.
Okay, very good. Thank you so much. Okay, so in your exam, you will be tested very similar questions, okay? I'm going to give you a question like, say, find the volume of a solid obtained by rotating the region bounded by the given curves about a specific line, okay? For the specific lines, I'm not going to give you very hard questions. So the specific line will either be what? The x-axis, or it will be what? The y-axis, okay? So either x-axis or y-axis will be our specific line. I'm not going to let you rotate something about any other lines other than x-axis or y-axis, okay? Because rotating about x-axis and y-axis, that's a very most basic type, okay? In your textbook, they may let the region, let the area, bounded area, rotating about x equals 1, which is vertical line, or y equals 2, something else, it is even harder. I'm not let you do that, okay? We're only going to rotate about x-axis or y-axis, the very basic type, okay? So now let's look at this question, okay? So what is a bounded area? What is a bounded region? Let's figure out the bounded region first. Draw a picture and then figure out what kind of volume we should find out and what is a bounded region. What is a bounded region? Y equals x plus 1, right? So what is that? Straight line, right? Do you know how to graph the straight line? Sketch straight line. Now x equals 0, y equals what? X equals 0, y equals 1, right? One key point. When y equals 0, x equals what? Negative 1. Yes. You're right. This is one line, okay? Y equals 0. What is y equals 0? Is that x-axis? Yes. Okay, so our region will be bounded by this line, and what is x equals 0 as a line? X equals 0, this is what? Y-axis. Y equals 0, that's x-axis, right? And then also the line, vertical line, x equals what? 2, right? Guys, do you see the 4 lines? This line, and then 2 vertical lines. So what is a bounded region? Can you tell? Let me use a red pen. The shaded area, this is trapezoid, right, is our bounded region. Do you see this? You guys? Okay, so we cannot take actual parts, okay, just this trapezoid. We're going to rotate this trapezoid about what? X-axis, right? About x-axis. So rotate this thing about x-axis. What kind of the solid can you imagine we'll get? I'm going to draw it like this. Briefly, I say, if we rotate this trapezoid about x-axis, we can have a solid look like this. Do you agree with me? It's like a hat, right? It's like think about a hat or something, Some hat looks like that. What?
A lampshade.
A lampshade, right? Or a bowl, right? A bowl. So when you go to ice cream store, they give you a cup like this. They put ice cream inside, something like that. I think about a paper ball, okay? With a base, what? A circle. Another top base is what? A circle, right? And then, well, okay, so this is a solid we have by rotating this trapezoid about x-axis. Can you imagine that as the solid? Okay, so this is our solid. How can we find the volume of a solid look like this? This is a bread, right? Remember how we find the volume of the bread? What do? We cut it by using a knife, okay? And then pass through when x equals what? X, okay? And then we figure out the area of this intersection, which is a of x, and then we integrate from the a to b, right? A to b. Now, for our solid, x varies between where to where? 0 to 2, right? 0 to 2, okay? Because this ball is bounded between what? When x equals 0 and x equals 2, okay? So the volume, okay? The volume is what? Should be an integral for x varies between 0 to 2 and a of x dx, right? dx. So, what is a of x? Where is a of x? Between 0 and 2, we're going to find any arbitrary x between 0 and 2. Any arbitrary x, okay? And what do? We're going to use a knife to cut. We use a knife to cut this ball, okay? And pass through what? X. And then, so what can we get? Can you imagine what can we get if we use a knife to cut it? What will be the intersection? What is the shape of the intersection? Can you imagine? See, this is x. Okay, so this is a kind of the center of that intersection. What shape of the cross-section area it is going to be? If we use a knife to cut it, every time we should get what? A disc or circle, right? Why? Because we will do, right? Like, that give us a circle, right? This is a circle, this is a circle, and then no matter what, how we cut it, and then, every time we should get what? A circle or a disc. Can you imagine that, guys? Okay, so the cross-section or I call it the intersection or whatever, okay, cross-section or intersection is going to be what? A disc. Okay, so the thing is, what is the radius of this disc? What is the radius of this disc? So this is our disc, right? This is our disc, right? What is the radius of our disc? What is the length of the radius? Remember, this point is a point on this line, right? What line? Y equals x plus 1, right? So when x equals x, what is the y value here? This point has coordinate x and what? Y, right? What is y? Can you tell? X plus 1. Do you see that, right? So what is the length of this radius? What is the length of the radius? Should be what? X plus 1. Right, guys? Yeah. So x plus 1. Because this is when x equals x, and then because this point is on the line y equals x plus 1, so this point must have coordinate x plus 1. What is x plus 1? X plus 1 is y value for this point, okay? And also, from 0 to x plus 1, this is the length for the radius, okay? Radius of this disc, x plus 1. Oh, it doesn't show. It should show, okay? So this is our a of x, okay? So this is a of x, okay? This is a of x, this is a of x, guys. So how to find the area of this a of x? The cross region, or, intersection area. Because it is what? This cross-section area or the intersection area is what? A typical disc, okay? So the area for this disc should equal what? Pi times by what? Radius square. You guys agree with me, right? Pi r square. R equals what? X plus 1. It doesn't look very clear, but you see, this is x, okay? Here, this is what x, okay, this is x, and then the length of this is going to be x plus 1, which is a radius, okay? So we have pi r square, which is pi times r square, okay? So if we know the area for this shaded, a of x, okay, yeah, area for this intersection area, okay, yeah, region, okay. So we're going to integrate from when x equals 0 all the way to 2, and then that will give us the volume of this ball, right, ball. All right, so the thing is, how can we compute this integral? pi is what? A constant. So we put it in front of the integral, yes, okay? And then to integrate x plus 1 square. So x plus 1 square, let's write it out. It gives us what? X squared plus 2x plus 1, right? And then what are the antiderivative for these terms? What's x squared antiderivative? 1/3 x to the cube. X squared, 2x, what is antiderivative? X squared. For 1, what is antiderivative? X varies from 0 to 2, right? Evaluate from 0 to 2. Because this is a definite equal, this is capital F. By using the evaluation theorem, we have to evaluate capital F at 2 minus capital F evaluate at when x equals 0, right? So that will give us pi times by what? 1/3 times by 2 to the cube plus 2 to the square plus 2 minus what? Replace x by what? 0, right? So we should have a 0 plus 0 plus 0, which is 0, right? And then pi times by 2 to the cube, what is it? 8, right? 8 over 3 plus what? 2 squared is what? 4. 4 plus 2 is what? 6. And then this is 6 should be written by what? 18 over 3, right? Can we? So eventually answer is what? 8 plus 18, 26 over 3 times by pi. See, the calculation is not bad, right? Calculation is not bad. The thing is, the first time when we encounter this formula, oh, what is A of x? We have to understand, oh, the intersection, this region is what? Intersection region is a disk. And to find the area for a disk, we need to know the radius. How to find the radius? From, oh, when x equals x, y equals what? X plus 1. That gives us the radius. Pi radius square and then integral. So that's good for this question 1. You guys, that's good? Understand that? Okay, very good. Now let's try number B. Y equals x to the cube. Okay, the region, is bounded by y equals x to the cube and y equals x, while x is greater than or equals 0. Rotate that bounded region about x-axis. Let's see what we can do this time, okay? Y equals x to the cube. How to draw y equals x to the cube? When x equals 0, y equals 0. When x equals 1, y equals what? 1, right? When x equals negative 1, y equals negative 1. So, briefly, y equals x to the cube looks like this, right? Briefly picture. You guys, right? Yeah, I should graph it like this because it's more flatter, okay? It's more flatter because if you choose x equals 1/2, we will only get what? 1/8, right? 1/2 cube 1/8. There is more kind of more flatter, okay? Looks like this. Okay, this is a y equals x to the cube. What is the other line? Y equals x. What is y equals x? It is a straight line. Right? It is a straight line. And then here, it says, okay, the boundary region, actually you can tell two parts, okay? However, we restrict our x is greater than or equals 0. So do we have to worry about this part? We don't. We only need to worry about what? When x is greater than or equals 0, and then bounded by y equals x to the cube, and y equals what? X. Guys, do you see that? Okay, so actually, okay, the boundary region is this, right? Y equals x to the cube, y equals x, when x is greater than or equal 0, the shaded area is what? The bounded region, right? So what do we do about this bounded region? We rotate it about which axis? X-axis, right? So can you imagine what we can get? The outer line, we should get what? If we rotate about the x-axis, it should give us what? A corn, right? A corn, okay? How about the inner curve? Rotate about x-axis. Outer straight line or line segment give us what? A corn. And inner curve, once we rotate, we should get what? I don't know how to graph that, but yeah, it gives us like something, like a flower or something, like this, right? Yeah, what?
Funnel.
Yeah, funnel, yeah, like this, okay. So that, okay. All right. So this is like a trumpet, right? It's like a trumpet, something like, goes like that, okay. All right, so what is a solid region for us now? It is what? It is a corn subtracted by what? This inner solid, right? So our solid is only the solid region bounded by this, this region, right? So it should be what? It should be a corn subtracted by this open area, right? So our region is, our solid is that, right? All the thing is, how can we find such a volume of a, solid looks like that? What should we do, guys? I'm going to draw a picture more larger. Okay, so this is larger. How to find the volume of this? What should we do, guys? Cut it, okay? We're still gonna cut it, okay? And then we're gonna use our knife to cut this solid when x equals what? When x equals x, okay? So we know for this solid, it is bounded between when x equals what to what? 0, right? And then this is when x equals what? Can you tell? This is when x equals what? 1. How do we get the 1? See, this is 1, y equals x to the cube. This is y equals x, okay? Because these two curves intersect. They must have the same y-axis, right? Same y-axis. So we let x to the cube equals x, right? So we let x to the cube equals x. Let's solve for x and see what is what is x coordinate from this point, okay? What is it? Should be what? x cubed minus x equals 0. x squared minus y equals 0. x plus 1, x minus y equals 0. So actually you can get 3 x values, 0, negative 1, and 1. This means when will the two curves intersect? When x equals 0, do they intersect with each other, this line and this curve? Yes or no? Yes. When x equals negative 1, do they intersect? They do, right? When x equals positive 1, do they intersect? Yes. So that means this is 1, okay? So that means our solid, after we rotate, must vary between where to where? 0 to 1, right? So here, this is 1, okay? So later when we integrate, we need to find out, what is the a to b value? 0 and 1. So our solid is bounded between x equals 0 and x equals 1, okay? Well, the thing is we need to find what? So volume equals integral from 0 to 1 dx, okay? And we need to find the area of the intersection, right? Intersection. So what is our intersection? Say for example, we choose an x, any x between 0 to 1, okay? So this is x, what do we do? Use a knife, cut through this solid, and then pass through what? When x equals x. What intersection can we get? This is x. Okay, so I'm going to put x here. So if we cut, what can we get? If we cut the outer solid, outer layer, we should get what? A circle, right? And if we cut it, through the inner curve, we also should get what? A circle, right? Our solid is between what? It is between the two circles. So actually, what should we have? We should have a disk. Guys, can you imagine that? Okay, actually, this intersection, okay, is going to be a disk. I'm going to write this, okay, larger. So this outer circle comes from what? When we cut the outer layers of the solid, okay? This circle comes from when we cut it through the inner layers of the what? The solid. Can you imagine? Can you see that, guys? Okay, so the intersection is a disk, is a washer, sorry, it's not a disk. This intersection is what? A washer, okay? For a washer, how do you find the area for a washer? How do you find the area of a washer? Okay, so here actually it's summarized on the third page of the notes, okay, the notes. In general, we calculate the volume of a solid of revolution by using the basic definition formula, okay? So either V equals from A to B, A of x dx. This is what we're currently doing, okay? Later we'll do this second case, okay? So I'm not mentioning it right now, but we'll mention it very soon, okay? And then we find the cross-section area or the intersection area, okay? A of x or A of y is in one of the following ways. Either the cross-section is a disk. If we have a disk, what should we do? How do we find the area for a disk? Area will equals what? Pi times by what? Radius square. Okay, this is one case. We did it in the previous question, right? Or if the cross-section is a washer, how do you find the area of the washer? For the washer, we may have an outer radius and also a inner radius, right? So the area for the washer should equal what? Pi times by what? The outer radius, which gives us the area for the outer circle, and subtract by what? Pi times the radius of the inner circle. That gives us the area for the washer. You guys know how to find the area for a washer? Everybody? That makes sense, right? Area for a washer means pi times outer radius square minus pi times inner radius square, right? Now for our question, this time in the question, how to find the outer radius and the inner radius? When x equals x, outer radius is this, right? How do you figure out what is the length of the radius? We have to look at this point, right? This point. This point must have coordinate when x equals x, y equals what? What is the equation for this outer straight line? It is y equals x, remember? Okay, so when x equals x, y equals what? X. So the outer radius is what? X. That makes sense, guys? How do you find the inner radius here? It doesn't, it's hard to see. When x equals x, y equals what? Yes. Okay, so this point must has coordinate what? This point has coordinate x to the cube. So the radius, well, the radius of this inner circle is what? X to the cube. Okay? So this is, yeah, I would say, this is x, okay, and this is what? X to the cube. It's hard to understand, right? It's not hard, right? Is it hard? No? Okay. Alright, so how do you find the area of this intersection? Okay, it's going to be what? Pi times by, what is outer radius? X squared. Minus pi times by what? What is inner radius? X to the cube square. You guys, feels good? Alright, so this will equals what? I'm going to rewrite it as pi times by x squared minus what? X to the what? Cube. This is a of x, right? So we're going to integrate this thing from 0 to 1. I put the pi in front because pi is a constant. Okay? Pi. And then we have what? X squared minus x to the cube. Actually 6, sorry. You guys, that's good? And then let's compute it, okay? So pi, under the root for x squared is what? 1/3 x to the cube. X to the 6 under the root 1/7 x to the what? 7th, right? And don't forget to evaluate this capital F from what? 0 to 1. And then this will give us what? Pi times by, replace x by 1, 1/3 minus 1/7 minus x equals 0, right? Can you follow me, everybody? Okay, so 1/3, 7 out of 21, 1/7, 3 out of 21. So eventually it gives us what? 4 out of 21, right? 4 out over 21 times by what?